Hello everyone, welcome back. Here's vanAmsen with another live coding challenge. So today we are diving deep into a fascinating LeetCode problem 875. Yeah, Koko eating bananas. So let's dive in together. So all right, let's first understand the problem. We have Koko, a banana enthusiast, and she has n piles of bananas, and each pile has a specific number of bananas. Now, she has each hour to eat as many bananas as she can, and every hour Coco chews a pile, and it's at a speed of key bananas per hour from it. And if a pile has less than key bananas, she eats all of them. And the task is to find out the minimum speed key at which she should eat to finish all bananas within each hour of time. So sound fun? Right. So let's go through an example. So to make it clearer, say we have following piles. So it will be pile 3, 6, 7, 11, 3, 6, 7, 11, yeah. And our age will be A, so it's given in the task. And if Coco eats at speed of 4, so yeah, let's say speed or return at speed of 4 bananas per hour, she can finish all these bananas in 8 hours. How? So let's find out. So the key to solving this problem is binary search. Yes, you heard it right. We will perform a binary search on Coco eating speed, ranging from a minimum of 1 to the maximum pile size. And for each speed, we will calculate the hour it would take to finish the bananas. Yeah, all bananas for Coco. And depending on whether it's more or less than age, we will adjust our search. So let's dive into the code to see how this might work. So let me start implementing a helper function to calculate hour needed to eat all bananas with a given speed. So def hours will be speed and return sum of pile minus 1 divide without remainder speed plus 1 for pile in piles. So we start by defining a helper function to determine the hour Coco would need given a particular speed. And then we initialize low and high for binary search. So low high will be 1 and max pile. And now binary search. So while low less than high, mid will be low plus high divided by 2, and check how many hour it would take for Coco to eat all the bananas at this speed. So if our needed mid less than h, high mid minus 1 as in binary search, else you probably guess it, low will be middle plus 1 and return low. So classic binary search. Let's run it to see if it's working. So yeah, all good, working perfectly. Let's submit it for unseen test cases as well. So yeah, we passed, all good. So we beat 83% with respect to runtime, and also 21 with respect to memory. So probably it could be optimized a bit, but with respect to runtime, yeah, all good. 321 milliseconds. Previously, I got 309 milliseconds. So basically, quite in line and great. Now, our function work, and there we have it. Our solution worked perfectly, and this problem beautifully demonstrates how binary search can be applied in scenarios you might not initially think of. I hope you enjoyed solving this with me, and don't forget to like, share, and subscribe for more coding adventure, tutorial challenges, tech, machine learning, and much more. And until next time, keep practicing, stay motivated, and happy coding!